பாய்க்கலாம். கவர்மெண்ட் மேல பிரஷரை போட்டு இம்மிடியட்டா சென்ட்ரல் ஜெயில இருக்கிற ஒரு கிரிமினல் அன்அபிஷியலா ரிலீஸ் பண்ணணும்னு சிஎம் என் தலையில குண்டை தூக்கி போட்டுருக்கான். என்ன பண்ற?
Good evening, one and all present here. I warmly welcome again for this FDP. Can you hear me? Can you hear me?
Yes, ma'am. You can start, ma'am. We can hear you.
Yeah. Good evening, one and all present here. I welcome again for this FTP, Cybersecurity for Industrial 5.0 Secured in Intelligent Enterprises. So already we have a tie-up with Ematrix Sharon sir. Last two classes were very interactive, and we have got so much of knowledge from you, sir. First day we have covered about the ethical hacking tools with secured, trusted. And second day, we have covered about first day itself, we have covered wired tools, and we have some knowledge about how to trace our IPs and port inside our websites. And we have some hands-on section from your sides. And thank you for that, sir. And second day, I got IOOT secured framework tools In that also, we have been interactively worked inside the tools. We liked it so much, sir. Thank you, Saran, sir, to be a uh, industrial persons with dry up and give you some sharing your knowledge. Today, at present, we are going to see about the digital twins and the cyber races. This is the latest trends what we are in the field. I hope this will be useful to every researchers and faculty members who are participate and make use of this. And we are also and join papers, what are all you are doing, kindly make our interactions with us and let me continue this journey to the next level. I hope so. Let me have a help of Saran sir and we'll be doing it. Saran sir, are you there?
Yeah, yes, ma'am.
Uh, will you please sort this, sir?
Yeah, sure.
Thank you, sir. Let me have a great enjoying with
Yeah,
you. Thank you.
yeah, sure. Uh, okay, good evening, everyone. So, this is our day 3. So, today we have the topic as a digital twin and cyber resilience, right? Okay. So, before entering into the sessions, first of all, we are going to know about what is digital twin and as well as the cyber resilience. So, have you heard about the digital twin technologies here before? So mostly we are thinking that the digital twin means just making a 3D model, right? So, but that is wrong. Okay. So actually, what is a digital twin? So digital twin is a live virtual copy of the physical system. Okay. So digital twin is an live virtual copy of the physical system. Okay. So for example, so there is a one machine. That machine have a temperature, pressure, humidity, or some sensors. Okay. So every second, those sensors values are sent to the computers and then the computer creates the another machine virtually. Okay. That machine is called as a digital twin machine. Okay. So what is the use of the digital twin, sir? So first of all, we have to know. Yeah, yeah. Tell me.
The physical infrastructure dependency could be reduced by means of
Yeah. So nearly it's all right. Okay. So first of all, is that the digital actually digital twin was a virtual machine, right? So is it works without the sensor? No.
I
Okay.
think
The
no.
virtual machine, yeah. So virtual machine doesn't have can able to run without the sensors. Okay. So as well as it can work without the communication, that also no. Without any communications, it can't able to run. Okay. So here, that is why the cyber security is most important in the digital twin also. Okay, why? Because without communication, without sensors, it can't able to run, right? So if there is a communication, there must be a one network layer. Okay, so if there is a network layer presence, there is a lots of possibilities for the cyber attacks. Okay, then what is cyber resilience? So just take one example. So there is a one device that detects the temperature of the boiler. Okay. The real system provides the temperature of 72 degrees Celsius. And what about the digital twin? That virtual machine also shows the 72 degrees Celsius. Okay. Now everything was running properly. Okay. But the suddenly hacker changes the 72 degrees Celsius to 120 degrees Celsius in the real machine. Okay. What will happen? There is a attackers enter into the physical devices. Okay. they are changing 72 degree to 120 degree Celsius suddenly, okay, what will happen? The control room, first of all, the control room thinks, what will they think? The boiler was overheated, or the factory may stop, or else a huge financial loss will occur because of stopping of machineries, etc. Right? So this is why, to prevent this, we are going to implement the digital twin security. Okay, is it clear? Okay, so now we enter the cyber resilience. Okay, so it's simple. So there was a one attack happened. Okay, and we are going to prevent the attack. To prevent that attack, we are using cyber resilience technique. And then what will happen? So there is a cyber attack happening. Okay, at the same time, we are preventing the system. How can we prevent the system? If there is an attack happen, just a minute. So, so hackers mostly attacking in the physical devices. Okay, so if the device was attacked, as we discussed in the previous session, the device will, if the device get attacked, means the original values are masked from the some technologies, right? So there must be no the original values will be displayed. Okay, but the system how will be operated, sir? The system will be operated by the use of digital twin virtual machine. Okay, so that machine, during that time, that machine will helps to continuing the machinery's work, and the system will survive the attack, and recovery will happens. Okay, this is why we are implementing the digital twin, and with use of digital twin, how we are implementing the cyber resilience. Okay, so today, what we are going to do means, so first of all, we are going to create one machine and as well as a digital twin copy. Okay, so we are going to see that how they both are communicating with each other, how the virtual machine and the physical devices are working. Okay, is it clear? Okay, so first of all, so by yesterday's session, we have seen only the security purpose, right? But today we are seeing the security plus recovery system. Which one is a best option? Security alone is a best option, or security plus recovery system? It is an automatic recovery system. Which one is a better option?
Recovery system, sir.
Yeah.
Recovery
So why?
system.
Because recovery system. So if there is only the security, we are only added the cyber security system alone means, if there is any attack happens means that security system stops the overall operations. There must be nothing happens inside the operation that makes lots of financial losses, lots of delays, and there may be possibilities for some machineries problem. Okay, but if we are implemented the security plus recovery system means the security system blocks the physical machineries activities, but the virtual machine are continuing its operation. Okay, so then the virtual machine become to recover the physical machine's activities again back to the server. Okay, so this is why the security plus recovery system is the best option for us. Okay, so we enter into our session. Is my screen was visible?
Yes, sir.
Yeah. Okay. So I'm going to enter to my Kali Linux. Okay, so for this, we are going to use the Python. Okay, we are going to use the Python coding. Okay. Okay, so I have opened my Kali Linux OS. So I'm going to open the terminal. Okay, so in Kali Linux, first of all, I'm going to create one folder to write our coding. Okay, so mkdir twin machine. Okay, I have created the folder called twin machine. Now I want to enter into that folder. Okay, so for that the command was cd space twin machine. So now my terminal was entered into that folder. Okay, see here. Okay. So now I'm going to create the two programs. Okay, so one was physical, another one was virtual. Okay, so first we are going to write a coding for the physical device. So that is nano space sensor.py. Okay. So here, so actually it doesn't have any physical machine or things. Okay, just simulating the things. I'm going to use the random variables that will generate the random values. Okay, so for that I'm going to import random, import socket, import time. Okay, so for generating the random inputs, I'm imported the random function. So for using here, it is connected to a network by using the socket level programming. So for that, I'm importing the socket. Then it will be runs based on the time. So I am adding here time. Okay. So first of all, who is my host? Who is my host? I'm going to use a localhost alone, right? So the what is the IP address of localhost means 127.0.0.1. Okay, this is the IP address of localhost. So that is my host. Then the port number. So my physical device was going to run in the port number 5000. Okay. Next, I am going to connect it with this socket. Client equal to socket dot socket. So while true. So this function is to generate the random variable, random values. Okay. So for first, I am going to take the random values of temperature. Temperature equal to random dot randint 20, 40. Okay. Next, data equal to temp temp Okay. So now I have generated the random value for the temperature and I have printed in the application. Next. It has to send to the client, right? So client dot send data dot encode so this command sends the data to the client, okay, which is connected with this socket. So next I'm going to print the value, print sensor send. Data. So we are giving the time for here. Why we are giving the delay time here? So it will wait for the 2 seconds. Why we are giving the 2 seconds? Why? Because if the network was trying to send the data, I mean, it takes some time, right? So for that, I have provided some delay that prevents the overlapping of data, overlapping and trafficking of data. Okay. Now I have completed the sensor coding. So I'm just going to close, save it. Okay. And next, now I am going to create the twin file, twin.py. This is my virtual device. Okay. So what is the coding of this virtual device means? So import socket. My host was 127.0.0.1. So port number was same 5000. Which port was the previous application running? It was application 5000, right? In same port, it was going to be run. Next, server equal to socket. Okay. So server dot bind host comma port. So this line was the important line. Server dot bind host comma port. This line connects the virtual machine with the physical machine. Okay. Okay. So next, server dot listen. Okay. It is connected with the physical device and it is going to listen the server. Okay. Next, I'm going to print the statement as print digital twin waiting. So for what purpose it was waiting? It was waiting for the data from the physical device. Okay. So next, connect address equal to server dot accept. Okay. So now it was going to connect with the server. Next, I'm going to print the connected status as well as in which address it was connected. Okay. So print connected address. So next, we are going to write the command for decoding the message which was received from the physical device and print the data. Okay. So while true data equal to connect dot receive 1024 dot decode. Next, print pin updated, comma, data, which data was updated. Okay. Now I have completed the virtual machine coding. Okay, sir. So now it both are completed, right? So now we are going to run this both the application. Okay. So before that, we want to install the library files, right? We want to install Python and Flask. Okay. So sudo apt install Python 3 Flask. Okay. So now it was completed, right? Okay. So now in this terminal, I'm going to run the sensor. In terminal 2, I'm going to run the print device. Okay. So first of all, we will run the sensor Python 3 sensor.py. Minute. Sensor.py, I'm receiving the error. Broken pipeline. Okay, so now the team was waiting. We will open the second terminal. Enter into print machine. Run Python 3 space sensor.py. Same error was repeated. I will check. Just a minute. So this was waiting. Cat sensor.py. Just a minute, I will cross check my coding. Okay. So actually, if I got to write this line here. So I'm going to write the connection program. I forgot to write it. So that is client dot connect host comma port. So I'm going to save it. We can run the sensor again. So see here, now my sensor.py is running, right? Okay. See here, the virtual machine also receives the same data, right? Here, so see, actually we write the coding to generate the data only in this sensor.py in which in physical devices alone, right? Okay, so the data was generated by the sensor.py program. Okay, but it was connected to the virtual device which is known as a twin.py. That device also receiving the same data. See here. Is it clear? Is it now it was understood for you how the digital twin was working. It is a virtual copy of the physical device. Is it clear?
Yes, sir.
Yeah. So now I am going to make one modification in my sensor file. Okay. So stop the coding. I need to open my sensor coding. So now I'm going to make one modification here. So here I'm going to add the values for humidity. Okay. Humidity equal to random dot rand int 40,80 data equal to just a minute. So CD definition nano sensor.py humidity equal to random dot rand int 40,80. So f dot temp comma colon. I'm going to print here humidity, right? Okay. So now I have made the changes in sensor.py alone, right? So I'm going to save it, run the file. Python 3 sensor.py. I'm going to open the another terminal. CD in machine. I'm going to run the Python 3 twin.py. So it was waiting. Now I'm going to restart the sensor file. See here, it's sending the temperature and humidity, right? So we doesn't change the any coding in our virtual machine, right? So see the virtual machine output. The same humidity also comes here. How is it possible? If there is any changes happened in the physical device, that will be automatically linked with the twin device. Okay. So now, what is the concept? We are going to store the twin data. We are going to store the virtual device data. Okay. So this is my virtual device. I'm going to stop it. If it is stopped, automatically the physical device also got stopped. Okay. So I am going to nano nano pin.py. Okay. Inside that, I'm going to modify the coding. So file equal to open log.txt, comma a. So next file dot write data plus /n file dot close. So run the pin file, the sensor file. Okay. So you will see the data are transmitting between these two devices, right? So now I am going to open the new terminal, third terminal, enter into CD pin machine. I'm going to open the log file. Okay. So cat log.txt. No subsequent, just a minute. .txt. Sorry, I have forgot to give the space before here. Okay. So now I am going to this is our server was running. Right. So servers are running outside. So again, once we will restart the servers. Pin was waiting for the command. So sensor is now sending command to the twin. So twin receive the command. Now I am going to see the log file. See here, what are the commands received by the virtual machine that are stored in the one text file? Okay, so now what we are going to do? Now I have stored the data. Okay, now we are going to write the alert function. Now we are going to write the alert function. Okay. Okay. So for that, I want to modify the twin. So I'm going to open the twin. Okay. So what kind of modification we will provide here? So first, if the temperature was above 35 degree means, it gives us the alert message. Okay. So for the command, we are going to write here. Okay. So where can we write? If we want to write inside the loop function or outside the loop function. Inside the loop only we are going to write the coding. Okay. So first of all, we are receiving the temperature value, right? So value equal to int data dot split one. Okay. So next, the condition. If value is greater than 35, print high temperature. Okay. So I'm going to save it. So application was running here. So please start the application. So now both the things are restarted. Just it. So there are some small error, right? I will check the error. So we are sending two data here. Okay. Temp underscore part equal to data dot split 0. So first we are running the twin machine. So twin was waiting now. Now we are going to run the sensor machine. It was sending the data. We are going to cat the catalog. Just a minute, we got again some error. So value in temp part. So again receiving the error. Just a minute, I will rectify the error problems. So it was running. Yeah. So now we are receiving the error, right? So okay. So now enter the cat. Okay. So now cat was updated. Okay. So this is how the physical device and the virtual machine communicating between each and everything. Okay. So we are storing the data from the virtual machine alone. Okay. We are not directly storing the data from the physical device. We are storing the data from the virtual machine. Okay. If there is an attack happens, then what will happen? Now we are going to see that. Okay. So where was the attack will happen?
Network?
In network layer, it will affect our physical device. Okay.
Not in data link layer, sir.
Yeah, yes. So it will affect our network. First of all, they are going to attack our network layer. Okay. By utilizing the network layer, they are going to entering into the datas. What are the data are communicated in that particular network. Okay. So if they are changing the data, means the data was from the physical device. Okay, not from the virtual machine. Okay, so they are going to affect the working process, working condition of the physical device. Okay.
This is through port or IP, sir.
So by actually they are, first of all, they are entering into they using the IP, they are entering into a network. Okay. After that, by utilizing the port number, they are entering into the application.
How they know the port number?
So by utilizing the port number, once I have entered the IP address, I know the IP address. So I have entered into the network layer. So there I am going to scan the network for the what are the ports, what are the, first of all, I am going to scan for what are all the devices connected to the network. Actually, we have done the association, right? What are all the devices connected in that particular network? Okay. Then I am going to run the scanning in the, again, to detect in which OS platform, in which kind of security system they are utilizing. For that, I'm going to find that those things by using the aggressive scanning. Okay, so now I got the application or what kind of operating system they are utilizing. Okay, and in which port number it was running. Okay, in which port number it was running. By using that port number, I'm trying to enter into that port. Okay, if that port was properly secured by some security reasons, means it does not allows us to enter into the applications. If there is attack happens with the data, first it will send us a warning. Okay, then immediately the cyber security developers or cyber security peoples can prevent the attack from attacks. Okay, if it is not possible, if they are already attacked the machine, means so the already predefined system will automatically enabled and mask the original data. This will stop the hackers little bit more. It will make the hackers to have some more time will taken. Okay. So for example, if there is a no masking, means they will directly take in the data within a 5 minutes. Means if there is a masking system will happens, it takes them to, if for example, these are the just example sections. Okay. So it will takes them to hack crack that code. It will takes up to 30 minutes. Okay. During that time, the virtual machine will recovers the physical device for its original operations. Okay. So it will what is the possibilities, means so it will recover the system. Okay, and the system may not get destroyed. Okay, and the what are the operations running over there, that will not stop immediately. So what are the operations running, that will smoothly going on, and the system will not get destroyed. Okay, this is the main reason we are using digital twin and with the cyber security resilience. Okay. Okay, so we see our next thing. So what's our next thing? So now we just developed the both the things, right? So we are now going to create, before that we analyzed in our network. Okay. Okay. So for analyzing the network, I'm going to open the Wireshark CD pin machine sudo Wireshark. Okay, so here I'm going to make the filter as TCP dot port equal to 5000. So capture it. See here. So this was the network analysis. By utilizing this only, the hackers can enter into our application. Okay. So it will show the, so we all know the OSI model, right? So from the physical layer to our network layer, all the communication, it gives you the all the information about that. Okay, which kind of we are using the TCP protocol. It was running on the port number. Just a minute, I will show you the full. It was running at the port number 5000. So source port was 5000, and the same time destination port was 35562. Okay, so the sequence number, acknowledgement number, and also which version we are using. So we are capturing the version 1. How many data frames are transmitted? How many packets are transmitted? Okay, all the details we will get here. Okay, okay.
So we can monitor the attacks also here, sir.
Yeah, right. If there is any attack happens, means either here our destination or source will modify. Okay, so definitely they are from the different IP address, right? Different device, right? So we can identify by using the destination or source IP address variations. Okay.
Suppose some official designation also it will be shows as an attack. No, how we differentiate this?
Once again, ma'am.
Suppose any official designations also sometimes it show in different IP, not in
Yeah.
the same IP. So that time we will be finding its attack.
So for that we have the port number, right? So we have the destination port. Why? Because so this is actually this concept was run on the same port alone. Why? Because the physical device and the communication between the physical device and the virtual device, right? So the digital twin will works only on this single port. So both the devices will be must run the single IP. Okay. If there is any third second IP will comes, means it does not depends on the physical or virtual machine. It is an another device. Okay, so but
Like
you asked me if
in
if
IIoT, sorry for disturbing you, sir.
yeah, yes,
In
ma'am.
in IIoT, it's everything in internet only
Yeah,
designation. So the sensor will be in different ports.
yeah,
In that time, how can we identify this is fake or
yeah, yes, ma'am.
attack or anything?
Yeah, yeah. So all the sensors are not going to directly connect with the network or any devices. Okay. So sensors are going to connect with the machine, which physical machines. Okay. That machine alone going to connect with the network layer. Okay. So not all the sensors are going to connect with the physical device alone. The physical device is going to get the data from the sensors and transmit to the virtual machine through the network layer. Okay, so the physical device alone going to connect with the network. Not all the sensors are directly going to connect with the network. Clear, ma'am?
Yes, sir. Yes, sir. Thank you. Thank
Yeah.
you for your explanation.
Yeah. Thank you, ma'am. So next, so we are now going to make some problems here. Okay, so we are a ethical hackers. Okay, so we attack only our own labs. Now I am going to attack my own network alone. Okay, I am not going to attack any others others network. Okay, okay. So just I'm going to close it. Okay, so nmap local host. So what was this shows that the port number 5000 using the TCP, it was in open state, not secured, right? So it was in open state, services UPnP service was running there. Okay. So by using this, attacker discover my network, right? So now I am the attacker of my network. So my network is running in the port number 5000 in IP address, in this IP address. Okay. So I have entered this IP address. Now I have scanned this IP address using the network mapping. So I got that the port number 5000 was running currently using TCP protocol and it was in open state. Why? Because this is currently running. Okay. Okay. So now I'm going to open another thing. NC space hyphen LBP 6000. Okay. So now I am going to make one fake transmission. Echo temp 120 or NC local host 6000. So actually this is an fake sensor, right? So because I'm just created a fake sensor and I'm going to send it to that file. Okay. So that was quoted. So now attack was happening here. Okay, what happening in our original terminal? Anything happens here? No, nothing was happened. Why? Why the attack was not happened here? Actually, I have made the attack here, right? I have changed the sensor value as 120. Okay, so I will explain. Okay, so stop it. Stop this. Now I am going to stop my sensor. Now the physical device was in off condition. Okay, so what is the condition? The physical device was currently not running. So what about our twin machine? The twin machine was waiting for the command. Okay. Okay. So now I am going to scan this network. I got the port number 5000 was running. So I am going to create one duplicate sensor NC localhost 5000. Temp 120 space pretty 80. So send it. We'll check. See here. The duplicate data was received, right? What is happened here? So actually our actual physical device was not running, right? See here, our sensor was in off mode. But and the hacker entered into the port and I have sent the duplicate value, and I have sent the duplicate value. This also updated in the virtual machine. What does the virtual machine does immediately? So a virtual machine does immediately does it does not stop its operation. Okay, it continues its operation. Okay, so now we got notified by the some attacks was happened. Okay, now how we can able to find that? How can we solve that? So before that, we have another attack. 1 minute. So my both the relays are running now. If there is an one or more virtual machines as available means, so we can use a MITM attack. Okay, so that is a pseudo, just I'm demonstrating. If it is possible, I will show you. Enter cap. Okay, so by using this terminal, okay, so this is it will be. So now it's start finding the ports. See here, so it was listening to this IP address and the network IP. So it gives us there is a 34 plugins available, 42 protocols dissected, and 46 ports are monitored. And we are using the TCP OS fingerprint. We have the TCP OS fingerprint. Okay, so by using this, if there is a lots of virtual machines, we can easily able to configure this. Okay, so I will cancel this. So now the cyber resilience. Okay, this is our final concept. So as of now, we've seen that how the physical device and virtual device combine together and work with application. So this is a digital twin concept. After that, we are demonstrating that how the attack will happen. Okay. So now we are going to see the cyber resilience. Now we are going to do the cyber resilience. Okay. Cyber resilience itself, it in coding developer side also, they must write something. Okay, they must write something. Okay, so what can they write? Where can I modify the code?
In any user dashboard like that. So,
Not in user dashboard. Actually, if you are counting the user dashboard, we are sending the error message to the dashboard. Okay, so currently we have the two codings. One was a physical device, another one was an twin device, digital twin device. Where can we rewrite the code?
in response,
Yeah. Okay. So in our digital twin, we have to write these things. Okay. Okay. So first of all, I'm going to open my twin, nano twin. So already here I have a one coding, right? If value was less than 35 means it gives the high temperature. Okay. So now I am going to add here, if value is less than 0 or value is greater than 100 means print possible of attack. Okay. So give the conditions. Continue. So
you are
start.
trying to recover. I'm correct, sir.
Yeah.
You are
yes.
trying to
So-
recovering the attacks.
Yeah, right. So if there is any attack happens means it must be notified to the peoples, right? So for that, if there is an unmodified, we know the scenario, we know the industry scenario, right? If there is a sudden change in the temperature, means it may be mostly there is a 50-50 percentage chance of percentage, right? So there's 50 percentage to actual machine default. There are also the 50 percentage for the attack, right? So that must be notified to the user, right? So it gives the alert as there is a possibility of attack. Kindly check like that. Okay. So I am going to start at the twin
So
device.
your detection, it's
Yeah, yes, ma'am.
it's not recovery.
So not recovery.
Identify the
for,
deductions.
so it was
Identify
identified.
the threads.
Yeah, so now this is identifying the threats, but while this happens, means the physical device will be stopped. Okay, what will happen? The physical device will be stopped, but the twin device continuing its operation. Okay, so because of that continuing that operation, the device will not get destroyed, and we can't get any losses. Okay, it prevent from us from the losses. Okay, so
Oh,
now, yes, ma'am.
putting equipment like a
Once again, ma'am.
predicting equipment like a
Predicting equipments like AI means so you're using
this.
you're asking for AI tools.
No. It's help that digital twinning is predicting. Am I correct? It's
Yeah,
sort
yes,
of a
ma'am. It's
AI
just
only.
predicting.
It's a sort of AI.
Um, so like that, ma'am, but not like an AI. Okay. So actually, what are the operations done with the physical device? That all the operations are captured by the digital twin alone. Okay. So we are instructing the digital twin that if there is sudden changes in the behavior of physical device means just intimate us and make him to stop. Like this, we are writing the code to the digital twin device. Okay. So now what will happen means, so like how means there is like a security guard. Okay. So there is a security guard in our play area. There is some children are playing. Okay. So we instruct the security guard to just monitor them. What are the things they are doing? If they are doing anything wrong means stop them and inform us. Don't stop others. Okay, like that, if you are instructed, that's the same thing that the twin device is going to do. So the device monitor all the things, what are the things doing by the physical device. It has all the operations. If there is something wrong, means it stops the operation of that particular device and continues the device operation of that particular device by itself. Okay, so by this operation, the physical device was actually stopped, but the virtual device carry the operation of physical devices. Okay, so even the absence of the physical device, so there must be a law. We don't get any losses or as well as an work progresses. Okay, so the immediately the developers came there, they are going to stop that attack, and the recovery will happen by the twin device. Okay.
Super, sir. Thank you. Thank you so much.
Yeah, thank you. Yeah, thank you. So next we are going to now our two devices running, right? So sensor was running and also this was running. So now I am going to again I need to NC localhost 5000. Now I am going to send the data. M 120, comma, multi 90. So we will see is the data was sent. We not received here. We not received here. Just a minute. So the connection was refusing. Just a minute. See here, we have received the 120-degree temperature. It gives us the possible high temperature, and also there is a possibility of attack error also, right? So by utilizing this acknowledgement, we can able to find if there is a actually attack has happened or else it was a really a machinery's problem like that we can monitor. Okay, so this is the concept of digital twin technology and the cyber resilience. So cyber resilience is nothing but if there is any attack happened, so we are going to prevent the loss of devices. Okay, it will automatically recover the devices. Okay, so is it clear? So if you have any doubts, if you have any doubts from this,
No, sir, super.
yeah, thank you, ma'am.
Audience, if you have any doubts or any clarifications, please ask.
No doubt, ma'am.
So if any doubts or clarifications needed,
Thank you, sir. Thank you for your valuable input for us. I think this will be possible when we get the IP address of our organization. Without knowing the IP address, we can't able to do it everything
Yeah, yes, ma'am. If you are going to enter into your IP address means we must know the your authorizations and tokens also. Okay. So now I have just demonstrated without any authorization because my network host doesn't have any authorization. I just I have just open port. Okay.
Yeah, yeah.
But whether we come with our organizations means, so there is a lots of securities are enabled. So first we are trying to break that securities alone. So if we are break that security means then only we can able to access the ports, we can access the devices as well as.
Since we are ethical hacking, we'll be get some permissions when we are going for this field. Otherwise, it's not possible for us to do
Yeah,
it.
yes, ma'am. If you are going
Yeah,
to demonstrate the particular hacking means you
uh,
first get a permission from the admins. If
admin.
they're allowing you and they
Mm,
provide you some ports, you can utilize these ports alone. You can just demonstrate the things by using that ports alone, ma'am.
yeah, okay. But we
Yeah.
learned a lot from you about the digital training. It's very great, and
Yeah,
we'll
thank
we
you, ma'am.
make use of this in the research work also.
Yeah,
And the
sure.
virtualization now and about digital twin virtualizations clearly with your delivery commands. So thank you for your so much for to spend the time, precious time to us, sir. Thank
Yeah,
you.
thank you so much, ma'am. Yeah, thank you.
Thank you, auditions. And your feedback link and questions will be posted in your WhatsApp group. And kindly complete this by today. Thank you.
Thank you,
Thank
ma'am.
you for your participant. Thank you. Thank you for your participant.